All right, so new week, new lesson. We're going to continue with chi-squared, okay? Now, the week before spring break, I know that we kind of worked with chi-squared. We did a lot of review over confidence intervals and significance testing. We did a little bit with chi-squared, okay? This week, I'm just going to try and break down chi-squared, make it as simple as possible. So right now, we're only going to do one specific instance, a very simple example of chi-squared, okay? So, just to break down chi-square again, because we might forget. All it is a test that can help us see if an observed value is different from an expected value. We all know that with probabilities, right, we expect things to happen. If I flip a coin, I'm going to expect that half the time I get heads, half the time I get tails, okay? That's expected. Observed is what we actually see when we do it. So I could actually run an experiment where I flip a coin 1,000 times, and I might see that I get 470 heads, 530 tails, okay? That's an observed value. So there's a difference between what happens in reality and what happens in theory, okay? Expected value is what would happen in theory. Observed is what happens in reality. Chi-square just measures the difference between the two. So far, we've done a couple chi-square tests through worksheets and our examples. We did a couple in class. We did a couple the week before spring break. Again, these notes are just going to hopefully clarify some things, make it a little easier to understand. So essentially, we're just going to be working through an example today, and I'll be kind of walking us through it. So I highly recommend opening these notes on Google Classroom and following along. Especially, this kind of setup is kind of janky. I haven't figured out a good way to do it. So follow along on Google Classroom just to make sure you know what's going on. You can actually see what's happening. So the example we're going through today, I've been nerding out recently. There's a lot of extra time, obviously, with what's been going on in the world. So I've been playing a lot of League of Legends lately. It's just a computer game. All you need to know for this example is that there's 4 main classes in the game, okay? Support, fighter, assassin, tank. Essentially what you can do is you just pick between one of the 4 classes. And this is a pretty good example to see how chi-square works in reality, okay? So essentially the people who make the game, they say that 15% of people play support, 45% play a fighter, 20% of people play an assassin, and then 20% of the people play a tank class, okay? They say these are the rough breakdowns of the percentages of what people play, okay? So this is what we're going to do. We're going to conduct a chi-square test to see if this claim that they're making, this is a claim, we're going to see if this claim that they're making, if it's true or not, okay? Do 15% of people actually play support, 45% fighter, so on and so forth. This is a claim. We're measuring it exactly like a significance test. Okay. The reason why we're using a chi-squared instead of a significance test or a confidence interval is because we're looking at multiple things here, all right? With a confidence interval or with the significance test, I was only ever looking at one thing, okay? I said, look at this one number, look at this one thing, measure it, is it true or not? There's 4 things here, right? There's support, fighter, assassin, and tank. All 4 of those things go into one claim. Okay, so I have to measure each of these 4 things as a part of one claim, as a part of one hypothesis. That's why a chi-square test is different from a significance test or a confidence interval, because there's multiple things that we need to measure here. All right, so HO, null hypothesis, that's the initial claim being made, remember? So the initial claim that they're making is that, flip back here, okay? They're saying that 15% of people play support. So under HO, there's 4 different things we're looking at. 15% of people play support. Okay, I believe it was 45% play fighter. I knew it was 20% play tank. What was assassin again? 20% play assassin. Okay. So that is the HO. That's the initial claim they're making. 4 different claims, essentially. 15 support, 45 fighter, 20 assassin, 20 tank. Alternative hypothesis. Remember, the alternative hypothesis is what we're supporting, okay? It's what we're measuring. So in this case, the alternative hypothesis, there really isn't one select thing we can do. As long as we can find that one of these are off, just one of them, then the alternative hypothesis is true, okay? We're just looking for inaccuracy in any of these four numbers, okay? So instead of having to measure only one number, we're measuring four. If at least one of them is off, then HA will be correct, HO will not be supported. All right, so we're going to bring in some tables to make this easy, okay? So to measure this claim, I went out, I played some games. I played 20 games, 10 people in each. That means that essentially I had 200 people, right? 20 games, 10 people in each, 200 people. Of those 200 people, 25 were playing support, 90 played a fighter, 50 played an assassin, 35 played a tank. This is what I observed. These are my observational values because it's what happened in reality. I observed it. It was in reality. Okay? So these are real numbers. The next thing you need to do when you're working through chi-squared is you need to find the expected values, okay? Observed is easy. It's just what you find in your experiment, to your survey, whatever. You'll have these numbers. You won't always have your expected numbers, okay? That's what we need to find. The way you find your expected numbers is you use the initial claim, okay? It's said that 15% of people should be a support. So if my total is 200 people, I'm working with 200 people. In order to find the expected value of support, I take 15% times 200. I'm taking 15% of 200, okay? Get out your calculator, you'll need this. So essentially what you do is you do 0.15 times 200. That gives me 30. So the expected number of people I should have seen playing support would be 30. For fighter, okay, we expect to see 45% of people play fighter. So you take 45% of 200, so 0.45 times 200. I should have seen 90 people play fighter. Oh, and look, I saw 90 people play fighter. Assassins. Assassins 20%. So you take 20% of 200. So 0.2 times 200 is 40. I should have only seen 40 people play assassin. Instead I saw 50. Lastly is tank. 20% times 200. It'll be the same as assassin. I should have seen, whoops, not 400, 40. I should have only seen 40 people play tank. Okay. So these are my expected values. Expected. These are what numbers I should have seen in theory. Okay. This is reality. This is theory. Once we have the observed and expected values, okay, we can start working through the chi-squared test, which is that table that I gave you guys in previous weeks, okay? The main thing people were asking about was the expected values. So hopefully this kind of helps you understand. The expected value is what you expect to see. And you use the claim numbers to find that. All right, so I'm going to fill out this chi-square chart. We have 4 categories, all right? We have supports, fighters, assassins, and tanks. 4 categories. O stands for the observed value. So I'm going to put the value I observed, the reality numbers, in here. Okay? So I saw 25 supports, 90 fighters, 50 assassins, and 35 tanks. Okay. And of course, the total was 200 people. Expected values. This is where I put my expected calculations. Okay. So I expected 30 people to play support, 90 people to play fighter, and then 40 people to play assassin and tank. Just these numbers right here. Again, that should add up to 200. All right. The next column, you take the observed value minus the expected value. It's okay to get negatives here. In fact, I expect it to happen. You should get some negatives. Okay. For support, 25 minus 30 is a negative 5. Fighters will come out to 0, 90 minus 90. Assassins, 50 minus 40 is 10. Tank, 35 minus 40 is negative 5. Okay. This turns out that should always come out to 0. O minus E will always come out to 0. Why? Because O minus E, if you look at the totals, 200 minus 200, this should always be 0. Next, you square whatever you got in this column right here. You're just squaring it. Negative 5 squared, 25. 0 squared, 0. 10 squared, 100. Negative 5 squared, 25. Find the sum, that's 150. This last column, O minus E squared divided by E. Okay, so in this first column, O minus E squared was 25. Divided by E is 30. Okay, so 25 divided by 30 is 0.83 repeating. Oops. Okay, so that's the O minus E squared over E. This one, you get 0, O minus E squared over E, 90, so that's 0. And you keep going. This, 100 divided by 40, 2.5. 25 divided by 40, 0.625. And then you add them all together to get this value. So 0.8, we'll just do a couple threes, plus 2.5, plus 0.625 equals 3.96. Okay, this bottom square is our chi-squared value. Okay, so I took 0.83 repeating, plus 0, plus 2.5, plus 0.625. That gives me this. And this is chi-squared. Chi-squared, you might see this sometimes, the x squared. This is the Greek value chi, so chi-squared, 3.96. Okay, we haven't done much with this number beyond finding it. Okay, today I'm going to introduce a little bit. Okay, the chi-squared number, so this 3.96, tells us how much the observed data deviated from the expected data. So the difference, how different are they? The bigger the number, the bigger the deviation. So this is saying out of 200 people, okay, we're looking at it out of 200, there's going to be a deviation of about 4, okay? What we don't know is how significant is 4, okay? Is that a big enough difference to say that HA is correct? Or is it small enough to say that HO is correct? Okay, that's what we need to find out. To find this, the one additional number we need to find is called the degree of freedom. All degree of freedom is you take your total number of categories and subtract it by 1. I have 4 categories: support, fighter, assassin, tank. So my DF is going to be 4 minus 1, or 3. So DF just equals categories minus 1. Okay. Degree of freedom, it's arbitrary, but it is important for us to know. Using the DF value and the chi-square value, you can find a p-value. All right? Normally what we would do is we would use a chart, a table. Obviously, I can't show you how to do that through a video like this. So for what I want you guys to do right now, or in the future when I give you these problems, just Google p-value calculator for chi-square test. You can Google it. There's a ton of calculators out there. What they'll have you do is they'll say, hey, what's your chi-square value and what is your df? So what you would do is Google that right now, input 3.96 for chi-square and a df of 3. It will give you a p-value, okay? I forget what it ends up being in this case. I think it's about 0.3. So in this case, the p-value would be about 0.3. I think it might be 0.3 exactly, I'm not sure. Anyways, is this test significant? You guys might remember alpha, the significance level of 0.05. Whenever we have a p-value, we compare it to 0.05. So, is 0.3 bigger than or smaller than 0.05? Obviously, it's bigger, okay? So what happens when our p-value is bigger than 0.05, okay? Either HA is correct or HO is correct. All right, and if you remember, when the p-value is bigger, HO is correct. When the p-value is smaller, HA is correct. So in this case, the people who make the game, their claim that these numbers, 15% for support, 45% for fighter, 20% for assassin, 20% for tank, those numbers are correct. Their claim, HO, is correct in this instance because p-value is bigger than 0.05. Okay. Hopefully that sheds some light on chi-square a little bit. I'll post some example problems for you guys in Google Classroom. Work through those. If you have any questions, just email me. Make a list of questions you have, and maybe we'll do a Google Meet or another video. But that is it for now.